Okay, in this video, we're going to talk about equations of a line and how to go back and forth between the various types of equations of a line. And the reason why there are multiple formats is that each of these have their own pros and cons. Okay, so as you move through these equations, you're going to see that each equation has its own strong point. So let's look at the first one. Y equals mx plus b is known as the slope-intercept form. And as the name implies, the slope is immediately evident right there. And the y-intercept is immediately evident right there. That's where the term slope-intercept comes from. So let's look at an example. Okay. Whenever you move from the generic formula, which is going to be on the left side of your screen, to the real world formula, I'll call that RW, notice that you are always going to see an X and a Y. What's going to change are the slope and the y-intercept. And you will be presented with formulas like the one on the right side of your screen, what I call the real world formula. Now, the benefit of the slope-intercept form is that it's great for graphing. Okay? That's its benefit. That's its strong point. That's why people love the slope-intercept form. So let's go and graph this. Okay, here it is. I rewrote it on this screen. The way you graph equations that are already in slope-intercept form is you find the slope, okay, we call that m. The slope is defined as the rise over the run. The run is always positive, 2 over 1. Then we find the slope-intercept. We take exactly what you see, sine and all, plus 4. So the y-intercept is defined as the point on the y-axis that this line crosses. So we move up to y equals 4 right there. That's the y-intercept. Then we employ the slope. Whenever we do the slope, we do the run first. The run is always positive. We move one direction in the positive x direction, and then we look at the rise. If it's positive, we follow those instructions and we go up 2. Run 1, rise 2. Here's our line. Right there. Okay, close enough. So easy to graph. That's the benefit of the slope-intercept form. Okay, let's now move to the point-slope form. As the name implies, when you look at a point-slope form or formula, you can see a point that's right here. It has an x and a y coordinate built in, and as the name implies, you could see the slope. The benefit of this form is that you can be given a slope, you can be given a point, and you can immediately write the equation. This on the left side of your screen is generic. The real world example would always include y and x. What's going to change is the y1, the x1, and the slope. Okay, they're giving you the slope and they're giving you the x1 and the y1. So all you need to do is plug these in to the point-slope formula. And you end up with y minus y1, which is going to be 4, equals the slope, which they give you, times x minus x1, which they give you. And that's it. So this is a quick way to get the form formula of the equation of the line that has a slope of 2 and contains that 1 point. Now here's the problem with the point-slope formula. It's not very helpful. It's hard to graph this. It's hard to find x and y intercepts. So if you're faced with the prospect of having to graph this, if they ask you on the question on your homework or a quiz, there's a line with a slope of 2 that contains the point 3, 4, write it in point-slope form, and then graph it. Okay, if they ask you to graph this, don't hesitate to convert this to the formula that's easy to graph. And what is that formula? The slope-intercept formula. Okay, and recall the slope-intercept formula is y equals mx plus b. So in essence, you have to solve for y. So what we're going to do is just take this equation and solve for y. And then we're going to pattern match it to something that we're familiar with in terms of graphing. So how do we do that? Well, if we're solving for y, we isolate y. First thing we want to do, let me rewrite this just for clarity. Here's the point-slope form. Okay, so we answered part 1 of this question on your homework. There's point-slope form. We're first going to distribute the right side of this equation. Then y is not yet isolated, so we're going to move this to the other side. And we're going to get y equals 2x minus 2. This is now in slope-intercept form. Here's your slope. Here's your y-intercept. We can graph this. So let's go to the other screen. Okay. Again, we've converted this, which is point-slope form, to this, which is y-intercept form. We know how to graph that. First, the slope equals 2. The slope is the rise over run. It's helpful, I think, to put the slope into a fraction with a hidden 1. We always do the run first. We go to the y-intercept. We take the y-intercept exactly as it is, sign and all. We go to -2 on the y-axis. We always do the run first, and it's always in the positive direction. So there we're running 1 and we're rising twice. Running 1 and rising 2 in the positive direction. Here's your line. Okay. Now, the third form of an equation is referred to as the standard form. And quite frankly, I'm not really sure where that name comes from. But let me just clean my screen up a little bit here. But the standard form is written in this format. ax plus by equals c. And c is a constant. Okay? So you'll be presented with a real-world example that fits this pattern. And here's an example of that. Okay? Again, as in all of these cases, when you move from the generic formula on the left side of your screen to the real-world example that you'll be presented with on a quiz or in homework, you always see x and y in the real-world example. What's going to change is the a value, the b value, and the c value. The a value, the b value, which is a hidden one here, and the c value. That is what's going to change. You are always going to see an x and a y in the real world. Okay. Now, what's the benefit of the standard form of the equation? The answer is it's easy to find the x and the y intercept. Okay? So, if they ask you on a question, find the x and y intercepts, this format makes that easy. Okay, so how do you find the y-intercept? The y-intercept is the point on the line. Okay, if I drew a line, any line, sorry. If I draw any line, okay, let's look at this line. The y-intercept is the point where the line crosses the y-axis. Okay, here's the y-axis, here's the x-axis. What is the x value at that y-intercept? The answer is 0. Okay, let's say the y-intercept was 4. The coordinates of this particular point would be x equals 0, y equals 4. So how do you find, and this, what I wrote in green, has nothing to do with this equation. I just made this up down here. So what you do to find the intercept is you find the point where x equals 0. So where does x equal 0 for this equation? If x equals 0, then you have 4 times 0 minus y equals 1. 0 minus y equals 1. Negative y equals 1. Multiply both sides of the equation by negative 1. Y equals negative 1. Okay. That's the y-intercept. Again, how do you find the y-intercept? You make x equal to 0. And that makes sense because look, x is 0 here. You didn't move left or right. X is 0. Okay, now let's move to the x-intercept. The x-intercept, as the name implies, is going to be the point where the line crosses or intersects or intercepts the x-axis. So let's look at this random line that I drew down below and look where it crosses the x-axis. That's the x-intercept. Look at the y value there. The y value is 0. Look, right here at this point where it crosses the x-axis, you're not moving up or down. You're at y equals 0. So what do? We replace y with 0. So now we have 4x minus 0 equals 1. 4x equals 1. X equals 1 over 4. That's going to be your x-intercept, for the equation up above, not for this line that I drew. Okay, so that's how you find the x and y intercept with standard form. Now, if you're presented with an equation in standard form, and you're asked to find the x and the y intercept, we just talked about how to do that. And then if they ask you to graph this, don't be nervous. Just convert it to your graphing equation. What is the graphing equation? Y equals mx plus b. Sorry. So what you do is you convert this equation, which is in standard form, which is great for finding the x and y intercept. Now you convert it into a form that's great for graphing, something that you understand. So how do you convert what's in the red box up above to the y-intercept method, slope-intercept form, which is great for graphing? How do you do that? You solve for y. Okay, so I'm going to rewrite the equation that's in the red box up there, which is in standard form, and I'm going to solve for y. So the first thing I'm going to do is subtract 4x from both sides, and I'm going to get negative y equals negative 4x plus 1. Then I'm going to divide both sides by negative 1 because y is not by itself until it is positive y. Y is going to equal 4x minus 1. Okay, so notice, when I solve for y, I divided all the terms by negative 1. on the opposite side. I did the left side to get y to positive y, and I got positive 4x minus 1. This is now in a form that you can graph. You know that this is the slope and this is the y-intercept. Okay? Just for completeness sake, let's go to the other screen and let's take a look at that. Here we go. We started in standard form. We solved for y, and here we are. Our slope equals positive 4. That's our rise over the run. It's helpful to put this into a fraction with a hidden 1. Here is our y-intercept, exactly how you see it. You start at y equals negative 1. You always start with the run, positive 1, and then up 4. Positive 1, up 4. Here's your line. Okay. Now what I'd like to do is move to some IXL problems that I had set up with screenshots. Okay, so let's start with this one. We have a line with a slope of 1/2 crosses through the point 8, 8. What is the point slope form of the equation? Okay, so we know, what do we know? Okay, first of all, what is the point slope form? Point slope is going to be y minus y1 equals m times x minus x1. Okay, they're telling you right here that the slope is 1/2. So immediately you can put 1/2 into here. Okay, we are trying to create the real world equation. Okay, and then they tell you there's a point, 8, 8. 8, 8. So here's your x1 and your y1. So all you do, ladies and gentlemen, is take this x1 and take this y1 and you plug it into this formula. Okay, so let's do that. Again, the x and the y stay the same. What changes is the y1, the m, and the x1. And they've given that to you. Okay, so let's say the slope is going to be 1/2. The x is just going to be written down. I'm sorry, I didn't do that right. Let's start again. I apologize. We're going to say y minus y1. What is y1? y1 is 8 equals the slope. What is the slope? They told us that. Look, it's right here. The slope of 1/2. They told you that. So then we're going to plug in 1/2 for m. Then we're going to write down the generic x, which is always going to be there. And then we're going to subtract x1. And that is your final answer. Okay. Let's go to another one. Okay. Clear the screen. Okay. Here we have a very similar problem. It includes this point. It has a slope of this. Again, the benefit of the point slope form is that you are able to get an equation quickly. Now, it's not a very usable equation. You can't graph from it. You can't get the x and y intercepts from it very readily. But nevertheless, it is the equation. Okay, so let's just follow what they're giving us. Here's a point. This is going to be x1. This is going to be y1. We write that down, the generic y. That's always there. Minus y1. y1 is 5. Equals the slope. They give that to us. -1. Then they say the x1 is going to be -6. So your final answer is going to be y minus 5 equals -1 times x plus 6. That's your final answer. Okay, let's do another one. Okay, what's our point slope formula? Y minus y1 equals m times x minus x1. Okay, here's your point. Here's your x1, here's your y1, here's your slope. Just plug it in. Y minus y1 is going to be 3. Okay, to review, here's our generic formula. The y and the x always come down to the real world formula. Now, what changes is the y1, the m, and the x1. They give that to you. The point is going to be 10, 3. Here's your x1. That's going to go here, minus 10. Your y1 is 3. That's going to go here. And your slope is 1/2. That's going to go here. There's your answer. Next one. Okay, this is pretty much the same. So I'm going to skip this one. Let's see, I think they start to change here momentarily. Nope, same thing. You know how to do this by now with ease. So let's get rid of this guy. Okay, I think this one I'm hoping is a little different. Nope, same thing. They give you the point. Here's x1, here's y1, here's the slope. You just plug it in. I don't know why I put so many of the same things in here. Hold on. Okay, this is a little different. All right. So what's going on here? They still want it in point slope form. So let's go ahead and write that down. Okay, but what do they do here? What's different about this? Here, they give you 2 points on the line, but they don't give you the slope. Okay, so they give you 2 x1, y1s, x1, y1, but there's no slope. No problem. You just find the slope using these 2 points. Okay, so what does the slope equal? The slope is going to be rise over run. The rise over run is simply the change. The delta triangle means change in y over change in x. How do you find something that changes? You subtract y2 minus y1 over x2 minus x1. Okay, so if they give us these 2 points, we're going to say, we're going to call this point 2 and this point 1. So this is going to be x1, y1, x2, y2. Okay, so y2 minus y1 is going to be 6 minus 8 over x2 minus x1 is going to be 4 minus 10. That's going to give you negative 2 over negative 6, which is positive 1/3. Okay, now look what we have. Now we have the slope. We have the slope and we have points. You could use either of these points now. If you get points and one of them has negative numbers and one of them has positive numbers, pick the positive number. It's easier to work with. Here they both have positive, so it doesn't matter. I'm going to choose this point, 4, 6. I have my generic formula here. I have my slope right here, which I had to work harder to get for this problem. In the previous problems, they gave it to us, but here we had to work a little bit to get it. And now I'm just going to plug in my point, 4, 6. So I'm going to have here y minus 6. Sorry, you can't see that. Y minus 6 is going to equal my slope, which I had to work to get, x minus 4. That is your point slope form. Given given 2 points, and that's it. Again, that's the benefit of the point slope formula. You can get your equation quickly. Okay, I think there's one more of these. Do it quickly. Okay. Here we go. What is the equation in point slope form? Okay, what's our generic for the point slope form? Y minus 1 equals m times x minus x1. Okay, they don't give us the slope. They give us 2 points, but they don't give us the slope. But we could find the slope from these 2 points. It's going to be the change in y over the change in x. It's going to be y2 minus y1 over x2 minus x1. Okay, so what is y2 minus y1? It's 2 minus 1 equals 1 over 6 minus 8, which is negative 2. And that's going to be negative 1/2 for your slope. So what do? We have 2 points. Again, these are both positive, makes it easy. But if you're given negative numbers in one of the points and you have only positive in the other, you take the point that's only positive. So I'm going to use 6, 2. So I'm going to get y minus y1, which is going to be my 2, equals my slope, which I figured out was negative 1/2, times x minus x1, which is 6. And that is your final answer. To review, I picked this number. And oh, don't get confused that when we did the slope, this was point number 2 and this is point number 1. That's a different scenario than when we go to part 2 and we're calling this y1, x1 to fit into this generic formula. Plugging into this generic formula is different than plugging into the slope formula. So don't get confused with point 1, point 2, x1, y1. Once you get your slope, which is point 1 and which is point 2 gets wiped out. We start all over. So when we say y1 and x1 here, it has nothing to do with the fact that we used 2's and 1's to get the slope. Don't get confused by that. We could very easily have plugged in 8, 1 in here. In fact, let me do that. Okay, so this very easily we could have said y minus 1 equals the slope times x minus 8. Okay, these are two same equations. And to prove it to you, let's go ahead and change both of these into y equals mx plus b. Let's solve for y for both of them. Okay, so we're going to have on this upper one, y minus 2 equals negative 1/2 x plus 3 Negative 1/2 times negative 6 is going to give us positive 6 over 2. We're going to have y equals negative 1/2 x. We're going to add 2 to both sides, plus 5. Now let's solve this one for y. Down here, I'll do it in a different color. So here, we're going to have y minus 1 equals negative 1/2 x plus 8 over 2. Y minus 1 equals negative 1/2 x plus 4. We're going to add 1 to both sides. We're going to get y equals negative 1/2 x plus 5. Okay, so let's review what we did. We were given the fact that a line passes through these 2 points. That's it. They wanted us to find the point-slope form. We wrote down the generic formula. They did not give us the slope, so we had to find it. We did 2 minus 1 over 6 minus 8, and we got negative 1/2. Okay, now we have the ammunition to create a point-slope form. We could pick either point. This one, call it point A or point B. First time, we chose point B, 6, 2. We just plugged in. Here's our slope. Here's our x1. Here's our y1. Then, if we're asked to graph this, we convert point slope into y equals mx plus b. How do we do that? We solve for y. We distribute, and we solve for y, and we got negative 1/2 x plus 5. We can graph this easily. We go to number 5 on the y-axis, and we run 2 in the positive direction, and we drop 1 in the y direction. Okay. Then we decided, okay, let's plug in this point to get the point-slope form. We're allowed to do that. We plug in x1, y1, and we get this. This is perfectly acceptable. If we're asked to graph that, we solve for y. We convert this into y equals mx plus b, which we're familiar with. So in summary, they're either going to give you the slope and 1 point, okay, if they give you the slope in 1 point, you just plug it in. Here's your slope, and here's your 1 point. Your 1 point is going to have an xy coordinates, let's say x1, y1, and you just plug these in. Or, the second situation is they're going to give you 2 points, and they're not going to tell you the slope. No problem. You just do y2 minus y1 over x2 minus x1. Okay, so let me give you the 2 points. They're going to give you x1, y1, and x2, y2. Okay? You plug everything in, then you find your slope. Now you are armed with a slope and 2 points. You could pick either one to create the point-slope formula.